Subpart H, Rigging, 29 CFR 1926.251. 1926.251 A1 General. Rigging inspected prior to shifts, as necessary during use, removed if defective. General. A2. Rigging equipment shall not be loaded in excess of its recommended SWL as prescribed in Table H1 through H20. General. A3. Remove rigging equipment from the immediate area when not in use. A4. Custom designed lifting accessories shall be marked to indicate the SWL and be proof tested prior to use to 125% of their rated loads. Scope covers slings and hoisting material handling equipment, alloy steel chain, wire rope, metal mesh, natural or synthetic fiber rope, conventional 3-strand construction, and synthetic web, nylon, polyester, and polypropylene. Examples are given below. Alloy steel chain. Permanently affixed, durable identification stating size, grade, rated capacity, and sling manufacturer. All attachments capacities at least equal to chain. Alloy steel chains continued. Job or shop hooks and links or makeshift fasteners formed from bolts, rods, etc., or other such attachments shall not be used. B5. Whenever wear at any point of any chain link exceeds that shown in Table H2, the assembly shall be removed from service. Example of chain wear on this slide. CP inspections made and based on A. Frequency of sling use, B. Severity of service conditions, C. Nature of lifts being made, and D. Experience gained on the service life of slings used in similar circumstances. Such inspections at least once a year, documented and available. 3 basic components. 1. Wires that form the strand. 2. Multi-wire strands that are laid helically around the core. 3. The core. Core is rope foundation. It provides support for strands, for loads, and bending. Core either fiber strands or independent wire rope core, IWRC. Wire rope cores. Fiber, IWRC, strand. How to describe any wire rope. Each strand contains 25 wires. Strand. Wire rope. Follow manufacturer's safe working load recommendations, or tables H-3 through H-14 for sizes, classifications, and grades not included in these tables. The safe working load recommended by the manufacturer for specific identifiable products shall be followed, provided that a safety factor of not less than 5 is maintained. Wire rope C2. Protruding ends of strands and splices shall be covered or blunted. Protruding ends. Example: seized in, tapered and welded in, seized or torch cut with N fused. Still N link. Wire rope continued. C3. No knots in wire ropes except where permitted. Haul back lines on scrapers. 4C. I splices must have not less than 3 full tucks. C4. II. Except for I splices in the ends of wires and for endless rope slings. Wire slings must consist of one continuous piece without knot or splice. C4. III. Eyes in wire rope bridles, slings, bull wire shall not be formed by wire rope clips or knots. C4. 4. Wire rope shall not be used if, in any length of 8 diameters, the total number of visible broken wires exceeds 10% of the total number of wires, or if the rope shows other signs of excessive wear, corrosion, or defect. Wire rope. U-bolt applied so that the U section is in contact with the dead end of the rope. Use table H20 to determine number and spacing of clips. Never shorten sling with knots or bolts. Protect slings from sharp edges. See the example given. Never saddle a dead horse. Wire rope. Never place fingers between sling and load when tightening. Never apply a shock load when lifting. C12. Slings shall not be pulled from under a load when the load is resting on the sling. C14. Fiber core slings shall be removed from service if exposed to in excess of 200 degrees Fahrenheit. Non-fiber cores used above 400 or below 60 degrees Fahrenheit follow manufacturer's recommendation. Wire ropes. C15. End attachments. Welding of end attachments, except covers to thimbles, shall be performed prior to assembly of the sling. Welded end attachments shall not be used unless proof tested by the manufacturer or equivalent entity at twice the capacity prior to use. Retain a certificate of proof test. Lubrication. Ropes and chains shall be regularly lubricated. Wire rope wear is based on 1. Loading, 2. Bending, number of times, 3. Number of use cycles. Change in rope diameter is critical for retirement. The area in a wire rope to check wear is where it travels over the block in the section from picking a load to lifting it. Wires need lubrication to prevent corrosion. Apply by spray, brush, or dip. Wire tends to wear flat on outer strands, especially where it travels over drums and sheaves. This slide gives examples of broken wires. Crushed wires. The correct way for inspection of a wire diameter. Example of kinking wire. Example of bird caging wire. General industry regulations. Wire rope slings. 29 CFR 1910.184 F5. Removal from service. 1. 10 randomly distributed broken wires in one rope lay, or 5 broken wires in one strand. 2. Wear or scraping of 1/3 the original rope diameter of outside individual wires. Natural and synthetic rope. Table H-15 through H-18 apply. Knots not used instead of splices. Remove from service if abnormal wear, powdered fiber between strands, broken or cut fibers, discoloration or rotting. Synthetic webbing. E. Synthetic webbing, nylon, polyester, or polypropylene. 1. Each synthetic web sling marked or coded to show name or trademark of manufacturer, rated capacity for the type of hitch, type of material. Synthetic webbing, don't use around acid or phenolics. Remove from service if acid or caustic burns, melting or charring of any part of the sling surface, snags, punctures, tears, or cuts, broken or worn stitches, or distortion of fittings. Synthetic webbing. E7. Safe operating temperatures. Polyester and nylon shall not be used at temperatures in excess of 180 degrees Fahrenheit. Polypropylene shall not be used in excess of 200 degrees Fahrenheit. Shackles and hooks. Shackles. Use Table H19 or use manufacturer's recommendations for higher SWL, provided that a safety factor of not less than 5 is maintained. Shackles and clevises. Check for wear in clevis. In the bowl of the saddle. Check the pin for straightness, wear. Check for distortion in the open end of the U. Shackles and clevises. Job or shop hooks and links or makeshift fasteners formed from bolts, rods, etc., or other such attachments can't be used. On the left is an example of the correct way to do it. On the right is an example of the incorrect way. Shackles and hooks continued. Hooks. Use manufacturer's recommendation. When no application manufacturer recommendations are available, all hooks shall be tested to twice the intended safe working load before they are initially put into use. Maintain a record of the dates and results of such tests. Basics of hook inspections. Wear, deformation, cracks, sharp nicks. Check throat opening. Check for wear and deformation. Check for twisting. Check for wear and cracks. Common causes of hook damage: backloading, tip loading, side loading. Only foundry hooks are designed for tip loading. Hook/load angles. In the example shown, A balanced 100%, B 1/4 off center 86%, C 1/2 off center 80%, D 3/4 off center 70%, E. Point loading 40%. Rigging safety. Rigging safety. Between the trolley hook and the load is rigging. Ropes, slings, chains. OSHA slings inspected daily. Proper storage when not in use. Suitable protection of rigging when in use. Items with sharp corners, etc. Rules for rigging safety. 1. Know the weight of the load. 2. Know the center of gravity of the load. 3. Make load attachments above the center of gravity of the load. 4. Select hitch that will hold and control. 5. Know the rated capacity of slings and hardware. 6. Select sling best suited for load. 7. Inspect all rigging before lift. 8. Protect sling from sharp surfaces. 9. Proper calculation of increased tension caused by sling angle on all rigging components. 10. Allow for D/D ratio on all slings. 11. Calculate reduction when using choker hitch. 12. Keep personnel clear from lift area. 13. Lift load a few inches, then check rigging. 14. Know limitations of all lifting devices used. 15. Lift slowly and stop slowly. The load on quadruple branch slings seldom have the load evenly distributed, among the 4 branches. For this reason, sling charts for quad branch slings set the load limit for quad branch slings to the equivalent rating for a triple branch sling of the same type. Straight sling. Total weight of the load is supported by a single leg. The working leg limit of the sling must exceed the load. Example of a choker sling. Example of a basket sling. Example of a bridle sling. Examples of various slings. Please examine the slide at your convenience closer. Spreader beams. Spreader beams can be used with a double vertical hitch to handle long loads. Reduces load tipping. Each leg will carry 1/2 the total load. Spreader beams must be manufactured for that purpose and have a rated capacity indicated. Calculating the load on sling legs. Divide the total load by the number of sling legs. Measure the sling from the load attachment point to the point where it connects with the hook or lifting device. This is L. Measure the vertical height from the top of the load to the hook or lifting device. This is H. Divide the length of the leg by the height of the sling. This slide shows the equation used for determining the load on each sling leg. Please study it carefully. Example, load equals 30,000 pounds. 2 load legs. Divide 30,000 pounds equal 15,000 pounds each leg if vertical hitch. Sling legs are 15 feet. Height from top of load to lifting device is 10 feet. 15 divided by 10 equals 1.5. Load on each leg is 1.5 times 15,000 equals 22,500 pounds. Center of gravity. A load is stable when the hook is directly above the center of gravity of the load. Estimate the center of gravity. Lift the load just enough to clear the ground. If the hook is not over the center of gravity, the hook will travel to the center of gravity. The following are examples of center of gravity. Please take a moment to study the slide. Questions. This completes the presentation of Subpart H, Rigging.